Hey, what's up everyone? In this video, I'm going to show you how to use integration by parts. The formula for integration by parts is this. So it's the integral of u dv is equal to u times v minus the integral of v times du. And don't worry, I know this looks intimidating, but I'm going to show you how to use it and where this formula comes from. And another thing that you need to know is the LIATE acronym. So the L stands for logs, the I stands for inverse trigonometry, the A stands for algebra, the T stands for trigonometry, and the E stands for exponents. So once you have your formula down, let's go ahead and get started with our first integral, the integral of x sine of x dx. So we see here that there is the x and the sine of x. So which group does x belong to? Is it log, inverse trig, algebra, trigonometry, or exponents? Well, of course, it belongs to algebra. And when we say algebra, we mean things like x, x squared, x to the power of 3, and so on. And how about sine of x? You guessed it, sine of x belongs to trigonometry. So the first circle will be a u, and the second one will be the v, right? So the u will be this part. So u is equal to x. And how about this part? Well, this part here, if you look at our formula here, you can see that we have the dv. So the rest of this, all of this will be dv. We have dv equals to sine of x dx. So we have the u and we have the dv. Now what else do we need? Well, if you look at the formula, we also need a v and a du. So let me show you how to find those. So to find the du, all you have to do is differentiate this. So we differentiate, we have du over dx. And what is the derivative of x? It's just going to be 1. And then du is simply equal to dx. How about v? If you want to find v, you have to integrate sine of x. So v is equal to the integral of sine of x dx. And the antiderivative of sine of x is negative cosine of x plus c. Now that we have all the necessary components, the last step is simply to plug it into the formula. So the formula, the integral of u dv, that's this part right here, and this is equal to u times v. So u is x. We have x times v, and v is negative cosine of x, and you just ignore the c. So x times negative cosine of x minus the integral of v du. So the v is again negative cosine of x, and you ignore the plus c, and then you have the du. So the du is equal to dx. So we put dx into here. This is the same as negative x cosine of x plus, because if you bring this negative sign out, you have a positive sign, plus the integral of cosine of x dx. So this is negative x cosine of x plus the antiderivative of cosine of x. And that's going to be sine of x plus c. And this right here is our answer. The integral of e to the power of x sine of x dx. So here we see e to the power of x. So we see an exponential. And then we also have sine of x, and sine of x is trigonometry. The circle at the very top, this one, is always a u. So we know that u is equal to sine of x. And the derivative, du over dx, is going to be what? So the derivative of sine of x is cosine of x. So du is equal to cosine of x dx. And how about the dv? So dv is going to be equal to e to the power of x and also dx, right? So because this is the same as saying sine of x, e to the power of x, dx. So we chose sine of x to be u, so the rest will be dv, according to our formula here. So dv will be equal to e to the power of x times dx. To find v, we need to integrate. So we have the integral of e to the power of x dx, which is the same as e to the power of x plus c. So using the formula, we have the integral of u dv. So this is the integral of u dv, and that's equal to u times v. So u is sine of x times v, right? And v is e to the power of x plus c. But you always ignore the plus c. So we have e to the power of x. Then we minus the integral of v du. So v is also e to the power of x, and you ignore the c, and we have du. And du is cosine of x dx. And to solve this integral, we have to use integration by parts again. So looking at our acronym, LIATE, we have an exponent, right? We have an exponent, and then we also have trigonometry. So the first circle at the very top is going to be the u. So let u1, let's say we have u1. u1 is equal to cosine of x. So du over dx. The derivative of cosine is negative sine of x. So du is equal to negative sine of x times dx. How about dv? Oh, dv will be e to the power of x dx. And to find v, we need to integrate. So the integral of e to the power of x dx is the same as e to the power of x plus c. So we have this integral, which is the integral of e to the power of x cosine of x dx. And that's equal to u times v, right? So u1 is cosine of x times v, which is e to the power of x, minus the integral of v, which is e to the power of x, and du. And du is going to be negative sine of x times dx. So this is the same as e to the power of x cosine of x. And if you bring this negative sign outside of the integral, you will have a positive sign. So we plus the integral of e to the power of x sine of x dx. Now let's go ahead and substitute this part into this part. And we're almost done. So let's move this up here. And as you can see, if we minus this expression, we will have, this will change to a minus sign. Now we have an equation, right? The integral of e to the power of x sine of x dx is equal to all of this, and you also see itself, which is the integral of e to the power of x sine of x dx. So all you have to do in this case is add the integral of e to the power of x sine of x dx to both sides of the equation. So here we will have 2 times e to the power of x sine of x dx is equal to, this here is e to the power of x sine of x minus e to the power of x cosine of x. And then this will be 0, so plus 0. Here we will divide both sides by 2. So we have the integral of e to the power of x sine of x dx is equal to 1 over 2 times e to the power of x, and we have sine of x minus cosine of x. And don't forget to plus c as well, because this is the integral, right? So the antiderivative must have the plus c. And this right here is the answer. The integral of t to the power of 2 times e to the power of t dt. So first of all, we see here we have t to the power of 2, and that's basically algebra. And e to the power of t is exponent. And the first circle at the top will be a u. So u is equal to the algebra one. So the algebra is e to the power of 2. We do the derivative. So du over dt is equal to 2 times t. So du will be equal to 2t times dt. And how about the dv? So we chose this to be u. And the rest, so dv will be equal to e to the power of t dt. And in order to find the v, you have to integrate. So we have the integral of e to the power of t dt, which is e to the power of t plus c. So our integral will be equal to u times v. So u is t to the power of 2 times v, which is e to the power of t, then minus the integral of v, right? So v is e to the power of t times du. So du is 2t dt. So let's go ahead and move the constant outside of the integral. To solve this integral, we have to use integration by parts again. So let's use the acronym LIATE. We have exponent, and then we have a t, which belongs to algebra. So this will be the u. So u1, let u1 equal to t. So du over dt is equal to 1. So du is equal to dt. How about dv? So we chose the t to be a u. So dv has to be e to the power of t dt. So v will be the integral of e to the power of t dt, which is e to the power of t plus c. This means that our integral e to the power of t times t dt is equal to what? We have u times v. So u is a t times v, which is e to the power of t, minus the integral of v, which is e to the power of t, times du. So du is just dt. So this is equal to t e to the power of t minus e to the power of t plus c. Now, we found out what this is, right? We found out what this integral is equal to. So let's go ahead and substitute this part into this part. And continuing on, we have t squared times e to the power of t minus 2 times t e to the power of t, 2 times e to the power of t plus, and that's all we have to do. So this here is the solution. The integral of ln of x dx. So you can think of this as 1 times ln of x. Now, using our acronym, we have the 1, which is the algebra. And then we have ln of x. And that belongs to the log, actually. The first circle at the top is a u. So our u is equal to ln of x, because ln of x is basically log base e of x. So the derivative of ln of x is 1 over x. So du is equal to 1 over x dx. How about dv? So dv is the 1 and the dx. So 1 times dx. So v is equal to the integral of 1 times dx, which is simply x plus c. And using our formula, we have u times v. So the u is the ln of x times v, and v is simply the x minus the integral of v, which is x, times du. And du is 1 over x dx. So this is the same as saying x ln of x minus the integral of 1 dx, which is equal to x ln of x minus x plus c. The integral of ln of x to the power of 2 dx. So in the previous problem, we found out that the integral of ln of x dx is equal to x ln of x minus x plus c, using integration by parts. Now let's make it one step further and say we have ln of x to the power of 2. So the way to solve this is very similar. You just pretend that we have a 1 times ln of x to the power of 2 dx. And using our acronym, we have the 1, right? So we have the algebra, and then we have the ln of x. So the ln of x is the log. So we have the u, and u is equal to ln of x to the power of 2. So this whole thing here. Now du over dx is equal to 2 times ln of x times the derivative of ln of x because of the chain rule. So the derivative of ln of x is 1 over x. So du will be equal to 2 times the ln of x times 1 over x times dx. So how about dv? Oh, dv will be 1 and dx. So 1 times dx. So v will be the integral of that, 1 times dx, which is simply x plus c. So our integral will be equal to u times v. So u is ln of x to the power of 2 times v, and v is simply x, minus the integral of v, which is x, times du. And du is 2 times ln of x times 1 over x dx. And as you can see, the x will cancel out. So we have x times ln of x to the power of 2 minus, and we also bring the 2 outside of the integral, so minus 2 times ln of x dx. And what is the integral of ln of x dx? Well, we already found out that is equal to x ln of x minus x plus c. And so we have x ln of x to the power of 2 minus 2x ln of x plus 2x minus 2c. But we can say let c1 equal to negative 2c. So now this is the same thing as saying plus c1, because c1 is equal to negative 2c. So here we go. This is our answer. The integral of x over 10 to the power of x dx. So we see two parts to this integral. First, we have the x, which is basically the algebra. And then we have 10 to the power of x. So what is 10 to the power of x going to be? Is it log, inverse trig, or exponent? Well, it is going to be an exponent because it's 10 to the power of x, right? So the first circle will be a u. So u will be equal to x. And du over dx will be equal to 1. So du equals dx. So dv will be equal to 1 over 10 to the power of x dx. This is the same as 10 to the power of negative x dx. So to find v, we have to find the integral of that. So the integral of 10 to the power of negative x dx. Now, let z equal to negative x. So dz over dx is negative 1. So dz is negative dx, and dx is equal to negative dz. And this integral is equal to 10 to the power of z, and dx is negative dz. Let's move the negative sign outside, and we have negative the integral of 10 to the power of z dz. And I clean up a bit because I need more space, so here is our current step. Now, if you remember the formula, the integral of a to the power of x dx, and the formula is equal to a to the power of x over ln of a plus c. So how can we apply this formula to here? Well, let's see. We have the integral. Let's just solve this part first, okay? Ignoring the negative sign. So the integral of 10 to the power of z dz is equal to what? Well, that's going to be 10 to the power of z, because a is 10. And here, instead of saying x and dx, we have z and dz. So we're going to use the variable z, and this is over the ln of 10 plus c. So continuing on, we have negative 10 to the power of z over ln of 10 plus c. And let's change the z back to the x. So we have negative 10 to the power of negative x over ln of 10 plus c. So that was quite a lot, but we're almost done. And let's go ahead and apply it using the integration by parts formula. So we have u times v. U is x. V is this part right here. Ignoring the c, we have negative 10 to the power of negative x over the ln of 10 minus the integral of v. So we need this again. So negative 10 to the power of negative x over the ln of 10. So we have the du, and du is simply dx. So this is the same as negative x 10 to the power of negative x over ln of 10. And if we bring this negative sign out, we have a plus. And we also bring the ln of 10 outside. We have 1 over ln of 10, the integral of 10 to the power of negative x dx. And we already solved this. Remember, we already found what this is. So that integral is basically negative 10 to the power of negative x over ln of 10 plus c. And we have negative x and 10 to the power of negative x. So 10 to the power of negative x is 1 over 10 to the power of x. I think it's better if we bring it to the denominator. So we have 10 to the power of x ln of 10. And here we have a negative sign. So this would be minus. And again, we bring the 10 to the power of x to the denominator. So we have 10 to the power of x, and we have ln of 10 times ln of 10. So that would be ln of 10 to the power of 2 plus c. And this here is the answer. The integral from 0 to 1 of arc tan of x dx. So using the fundamental theorem of calculus, we have f of 1 minus f of 0, where f of x is the antiderivative. So we need to find the antiderivative of arctan of x dx. And we need to use integration by parts. So we can pretend that this is arctan of x times 1 dx. Okay, so there are two parts to this integral. We see that there is the arctan, and arctan belongs to inverse trigonometry, and the 1 belongs to the algebra because it's a constant. So the first circle at the top is the u. So u is equal to arctan of x. And we need to find the derivative. So according to our formula sheet, we can see that the derivative of arctan is 1 over x squared plus 1. So we have 1 over x squared plus 1. So du would be equal to 1 over x squared plus 1 dx. And how about dv? Well, dv will be this part, right? Because this is the u, and the dv will be this part. So 1 dx. And v will be the integral of 1 dx, which is x plus c. So we have u times v, right? So u is arctan of x times v, and v is simply x, minus the integral of v du. So v is x, and du is x squared plus 1 dx. And I guess we could write it with x in the numerator like this. So let's go ahead and solve this integral. Now this integral here is easy to solve because we can just use u substitution. So let u1 equal to x squared plus 1. Because we already have a u, so now let's say we have u1. So the derivative of that is going to be 2x. So du is equal to 2x dx, and dx will simply be du over 2x. So this is equal to x over u, and dx is du over 2x. The x will cancel out, and we move the 2 outside of the integral, so we have 1 over 2 times the integral of 1 over u times du. So this is the same as 1 over 2 times the ln of absolute value of u plus c, and putting the u back to the x, so we have 1 over 2 the ln of x squared plus 1 plus c. Now, just note that x squared plus 1 is a function that looks like this. So we have this function is always positive, and that's why the absolute sign is redundant. We can just use normal parentheses. And we're almost done. So we have the antiderivative, f of x. So what is f of 1? We just need to substitute x with 1. So we have 1 times arctan of 1 minus 1 over 2 times the ln of 1 squared, which is 1 plus 1. So what is the arctan of 1? Well, that's going to be pi over 4. So pi over 4 times 1 is just pi over 4. And over here, we simply have ln of 2. How about f at 0? So we have 0 times arctan of 0. And let me tell you this will be 0. So minus 1 over 2 times the ln of 0 plus 1, which is 1. And the ln of 1 is 0. F at 0 will simply give us 0. So our final answer, f1 minus f0, will be pi over 4 minus 1 over 2 ln of 2 minus 0. And we no longer need that. So here is our final answer. So the integration by parts formula actually comes from the product rule for differentiation, as we learned in Calculus 1. So the product rule for differentiation is d over dx, f of x times g of x, where both f of x and g of x are continuous functions. So when you differentiate f of x times g of x, what you get is f prime of x times g of x plus f of x times g prime of x. This also means that the integral of f prime of x, g of x, plus f of x, g prime of x dx is equal to f of x times g of x. And this makes sense, right? Because the derivative of f of x, g of x is going to be this group over here. And so this means that the integral of this is going to be f of x, g of x. Another thing that I want to add in is that you might say, well, the integral of this is going to be this plus c, right? But in order for our proof to work, we're going to say that c is equal to 0. And since there is a plus sign here, we can split the integral apart. So we have the integral of f prime of x, g of x, dx, plus the integral of f of x, g prime of x, x, and that's going to be equal to f of x, g of x. We're going to simplify things by saying let u be equal to f of x, and then v equal to g of x. So when we differentiate du is equal to f of x, we get du over dx is equal to f prime of x. So du is equal to f prime of x times dx. As for this one, when we differentiate it, so dv over dx is going to be equal to g prime of x. So dv is g prime of x times dx. And we're almost done. So let's go ahead and substitute the u and v's into this equation. So here we have the integral, and g of x is a v. And then we have f prime of x and dx, and that's basically du, plus the integral of, we have g prime of x and dx, and that is dv, and then f of x is u, so we have u times dv. And finally, we have f of x times g of x, and that is u times v. Last but not least, we subtract both sides by the integral of v du. So we have u dv is equal to u times v minus the integral of v du. And this here is essentially our integration by parts formula. And that's basically it for today. I hope you enjoyed this video. I hope you found it helpful. And don't forget to subscribe if you haven't already and share with your classmates. Now, in the next video, I will show you how to use trigonometry substitution.